Hello guys, in today's tutorial we're going to try to replicate a mechanic from Ori and the Blind Forest. If you haven't yet played this game, you should play it. It's freaking amazing. Anyways, let's get to it and let me show you the mechanic real quick. So as you can see, that little animal, Ori, just jumped and now the time stopped, and she's using this projectile to throw herself to any direction she wants. So that's the mechanic. Okay, and that's it. Okay, so we have this, and you'll see that now that little guy over there will jump, and it will stop time. And as you can see, while time is stopped, the trees in the background and this animation still moves, but the objects themselves are still. They don't move. This will not move forward, nor this, nor this. As you saw in that moment, in that interval, this stayed in the same place, although the animation moved. Anyways, while that's happening, we have this arrow over here that shows us in what direction the animal wants to be thrown at, and you'll see then in a moment when you release the button, a big explosion comes out and Ori moves from here to around here and is thrown at a big speed into there. And also, if you didn't saw, the projectile went in the opposite direction. Now you'll see the projectile going in the opposite direction of the arrow. As you saw, the projectile is going there. Anyways, now we're going to replicate this, or try at least the best we can. So I'm going to find the shooter which shoots stuff and put it onto the project and give it a good direction, like maybe so. And let me see if the speed is okay. Okay, it's a bit quick, so I'll change it to 3. Anyways, if I play, you'll see that the player loses lives whenever he hits these collidables. So this is deadly and we want to avoid it, and we want to do it just like in that Ori clip that I just showed you. So let's create a new script over here on the player. Add scripts, Ori y bash or something else. It doesn't really matter. And the first thing that we want to do is to make that reach radius. So we want to make a radius so that from that radius on, the player can use that ability. So public float reach radius, and let's make it equal to 5, and so that we can see it on the editor, I'm going to put here void on draw gizmos dot color equals color dot something, gizmos dot draw wire sphere, and you want the center of it to be the transform of the player, so transform position, and the radius to be the reach radius. And that will tell us kind of the distance that we want the player to be able to find the projectiles. So of course it's a bit too big. I'll make it a bit smaller, like that, maybe something like this. Now how can we detect the projectiles? Well, we're going to use a thing that's called a circle cast, which basically will do a circle around the player like this one here. It will check everything that's colliding with it. If that something is the bullet, then it will use it to make stuff happen. Anyways, physics2d dot circle cast all, and you want it to be all and not just this, because you want to check every object that is inside that circle. Circle cast all, and we want the circle to be on the origin, on the position of the player, with the reach radius. The direction will be direction forward, and I'll explain that in a second. So transform that position, reach radius, and direction vector 3 dot forward. So basically what this vector 3 dot forward is 0 0 1, and 001 here in our game is the RGB is the blue axis, so it's this direction. And what we're doing is we're making it so that the circle, the normal to the circle is in this direction. So the circle will be laid out in this direction where you see that I'm pointing. If you would put, for instance, there a vector 3 dots right, the circle will be the normal to the circle will be this one. So the circle will be in this direction. But of course, you want the circle not to be like this, where it would detect everything, but to be like this and only detect what's near the player. So that's that. And this returns a raycast hit to the array. So I'm going to make a variable for that. Raycast hit to the array objects near. And we want to make the objects near be equal to this. Bam. And now we want to go through every single object and check it if we can use our ability on it. So the way that we're going to do that is to check if that object has a script. I kind of went through over this in the last tutorial. So it's basically like a secondary tag. I'm going to find the prefile of the projectile. Here it is. Add a script to it. I don't know, maybe bash shovel. Okay, this is the script or the tag script because it will be empty. And now here, all I have to do is to check if the object that we collide with has that script. And if it has that script, means that we can bash it. So to go through each of the elements of the array of an array, you use a for each loop. If you don't understand much about this, I'll put some links on the description that might help you. Anyways, we want this raycast hit to the object that is in the objects near array. So we're cycling through all of the raycast hits on the array. You will check if that object has a component. If that object dot collider dot game object dot get component. So if that object has a component bashable, meaning if this is not null, if it does have it, then we want something to happen. And for now it will be just like a debug.log bash. So you'll see that right now, if I go onto some near it, you'll see that these tags are appearing because I am near the balls. Anyways, you only start that animation where the time pauses and you do this when you click on the right button on the already defined first game. So I'm going to put here if input dot get button down fire 2, and this is the right button of the mouse. If this happens, then only then we want to check if this is happening. And I can also put here to instead of doing the bash to stop the time right now, so time scale equals 0, and of course that we want to make it back to normal later, but for now I'll just be showing you that this is working. So around here, so right now I'm clicking the right mouse button, but nothing is happening. But if I click it when I'm near these spheres, the time stops, and then it won't go back to normal because I didn't program that yet, but we'll get there. Okay, so that's it. Now when do we want the time to go back to normal? Well, when we put this button up. So I'll just make an else if that button is up, then turn the time scale back to 1. Time scale equals 1, like that. And of course we now did the time stop and start, but that's not obviously not the main part of this mechanic. What the purpose of it is to throw Ori around. So let's make part now. And when we want to throw Ori, well, in the game you throw worry when you stop pressing the right button, so in here. So you basically select a direction here, and when you release the button, it checks the direction that you selected and then throws Ori in that direction. So let's make here a variable for the direction, vector2 direction, and we're going to make it a vector3, and we're going to make it a vector3 direction because we'll need to use some coordinates that depend on the mouse, and the mouse has 3D coordinates, so to make it compatible you have to do it like this. Anyways, what is direction? Well, this direction is a vector that points out from the player to wherever our mouse is at the current point. For this is a way to do it. I don't think that's how they do it in a game, but that's a way to do it. So direction equals, and the mouse is always on screen coordinates, so we have to convert it into world coordinates, and to use that you have to use the main camera, so camera.main dot screen to world point. And what do we want to convert to world point? The coordinates of our mouse, so input.mouse position. There you go. So this is the endpoint, and as you know, if you want to point a vector from A to B, you have to do B minus A. So this is B minus A, and by A, for now it will be the player, but then we'll change this a bit, like so. So this calculates the direction, and like I said, the mouse has coordinates, but as z coordinates, but we don't want to care about those coordinates, so I'll just put direction z equals 0. And now I want to normalize the direction so that it has magnitude 1. Direction equals direction dot normalized. And now we want to throw Ori. And for me particularly, because of the way my player control is done, I have to do this thing where I make it able to be affected by outside forces. So, and I made a variable for that. Of course, if you are not using my controller, you probably won't need this. So this equals false, equals true, I mean, my bad. There you go. And now we want to give it a force. So get component rigid body 2D dot velocity equals the direction times the speed. And we haven't created that variable, that speed variable yet. Public float speed, and let's make it by default 20, something like that. And I think this is working right now. Let's check it. So oops, for some reason it's working here, so let's see what's going on. Okay, so what's happening is that we have to carry over that indeed we found an object. In we want to tell this if clause that indeed we have found an object. You just make here a bool can bash or something like that, which is by default false. And here, if we found it, we make it true. So this is can bash equals true. And by the way, you can here make a break so that it won't check through all the rest of the colliders. This is not important, it's just an optimization. Anyways, if this and can bash, only then it will be able to bash. So now we can't bash in here, but now you see that it's touched here, and now I set a direction, so maybe this direction, and you'll see that we go straight in that direction, and now this direction, it goes straight on that direction. And this is the basics of it. This is the basics of the program. Now of course I forgot to deactivate that variable again, and we'll fix that in an instant. All I have to do is to put here can bash equal to false again. And now let's go on to more stuff. So if you didn't see correctly, I won't actually show the video again, but when the game is playing and they right click, and then when they let go, they actually the player actually goes from this direction to wherever he wants to go. He goes from this point, so he goes from the sphere to wherever he wants to go. So instead of going from here to here, he'll go from here to here. So to do that, we're going to have to catch a reference to the object that we have collided. So I'll create here a reference to it, game object, bashable object, and if we found it, so here I want the bashable object to be equal to this object.color.game object that we found, like that. And now here I want to calculate the direction not from the player itself but from that object. So I just have to put bashable obj in front of it so that we actually are using this object that we just got from there. And like I said, we also want to make the player uh, go from this go from where the ball is to whatever he wants to go, and not from the position that he's currently on. So transform a position equals the bashable object dot transform dot position, and you'll see that this will make our player lose lives, because right now you see that if I right click and now I let go, our player is instantiated, is moved onto the ball, and we lose lives. So this is not our goal, but it's almost it. All we have to do is to, instead of moving the player exactly onto the ball, we'll move it to the direction that we want. So say we want to go this way, so the arrow goes here, so we put the player in the air. So but if we want to go that way, so I'll put the player in there, which solves this issue. So I'll just have to add here plus the direction. And if this is not working for you, just multiply it by a number, because what this will do is just add to it a vector with magnitude 1. And now you'll see that instead of being instantiated in the projectile, it will be instantiated in the direction that I want to go. So if I put the rolls here, it will be instantiated here. So bam, you saw it. And it will be put here, bam. And of course, even if you want to go down like this direction, it will be put here. In this case, it lost a life because it was too close, but that happens. And that's the basics of this. Now of course you can jump around from a ball to another. If I put them, I can even make here static ones, so I'll put here one and here another. And of course you can jump around on this one, go on to this one. Whoops, that went kind of badly, but you get it. Go from one to the other like that. Anyways, the basic mechanic is done. Before we end this tutorial, I'm just going to add a counter so that we can't stay here like this infinitely, because this will be kind of a OP mechanic. You have to react, man. So to add the timer, that timer will be a coroutine, so I'll put here I enumerator counter, which is a counter routine, and this routine want this routine to count the time. But how can we count time if time is stopped? Well, we will have to use properties that don't change even if the time is stopped, because right now this routine will operate when the time scale is equal to 0, so the time won't pass. So we can't use like we normally would, yield return new, wait for seconds, because no seconds will be happening while the time scale is 0. So instead, I'm going to use something that I saw online. I'll put link in the description. I don't remember quite well from where was it. Anyways, float pause time equals time dot real time since startup, and this time will never change no matter the time scale, because it's the real time. It's not dependent on the time scale, plus the time that you want to wait. So public float max time equal 1, and let's say that's the max time. And now while time real time since startup is less than the pause time, meaning while it hasn't passed this time, nothing happens. And when nothing happens in the counter, you just have to put there yield return null. so it can go to the next iteration. And if we haven't still let go from the mouse, so if time scale is 0, meaning we are still paused, then what you want to do is to make the time scale go back to 1, and that's basically it. And of course we have to start this timer somewhere, and we want to start it whenever we put the button down. So here, start coroutine, counter, like that. Oh, and this should be done here inside all the rest, only if we find the object. And you'll see that now if I go on to one thing and I don't do nothing, you'll see that it goes off. But sometimes something happens, something weird, and that's because I forgot that I have to turn this variable back to off so that you can't, so that this won't execute, equals to false. And now it will work like intended. If we don't do anything, the time goes back to normal and we can probably die and whatnot. Anyways, this is it. In the next tutorial we'll be programming the arrow, because if you didn't saw in the first video, there was an arrow around the players so that you could see the direction. This is just more of aesthetics than mechanics, because mechanics wise we have done everything. So that's basically it. Hi. Right now, when I was editing the video about the Ori, I just found out that I forgot to do something, which is to make the projectiles go in the opposite direction of the player. So I'm going to add that real quick before the tutorial ends. Anyways, whenever you bash, so whenever you input, you put the mouse up, and so you bash and whatnot, you want to also make the whatever you bashed on change its velocity. So all I have to do is to make bashable object dot get component rigid body 2D dot velocity, and make that equal to the direction times -1 times the magnitude of it, what it was, so times this dot magnitude. Save it. You'll see that right now if I right click and press the direction, the ball will go in that direction with the same speed that it has. So for instance, if I go this way and I say the ball goes that way, like so, the ball goes that way. And as you can see, this is working fine. Anyways, thank you for watching this tutorial, and see you in the next one. And that's basically it. In the next tutorial we're going to add the arrow to it. Now goodbye.